All right, so we've got a test due Thursday. So today is going to be our big super review day. So don't worry, I am going to get to some of those review problems just to make sure that we're clear, even though it's just going to be on solving for the unknown exponent. That's all it is. Evaluating logs, solving for the unknown exponent. But just to make sure that I do my job as a teacher, I want to make sure that you understand what does the log button actually do on this calculator. I've been calling it a magic trick this whole time, and I'm going to vaguely touch upon what it actually does. But I'm going to go more in depth with it on the next test. Okay, so not this coming test, but the next test, we're going to go more in depth as to the properties of the logarithm. So I just want to refresh our memory, even though I added some problems right here. So yesterday we evaluated the following. So what does the log button do? So log of 10 we calculated was 1. The log of 100 was 2. The log of 1,000 was 3. And the log of 10,000, 100,000, and 1 million will be 4, 5, and 6 respectively. Now, aside from it just being a total coincidence that we just count the zeros, what it actually is a reverse exponential equation. Because if I plug in 10 to the first power, I get 10. If I plug in 10 squared, I get 100. 10 to the third power is 1,000, and so on and so forth. So basically, when you plug in the log button with in the calculator, just log, you use a base 10. Okay, so the log of 10 means 10 to what power is 10? 10 to the first power is 10. Log of 100 means 10 to what power is 100? 2. Log of 1,000 means 10 to what power is 1,000? 3. And so on and so forth. Okay? So these correspond to one another. I'm just going to give you guys time to look at this with the pause button before we move on. Okay? So when there is no base given, in other words, it's not log base 2 or log base 3 or log base 4 and so on and so forth, it is assumed to be log base 10. So if there is no base, we call it the common log. We say it's the common log, but we just call it log. So if there is no base, it's automatically base 10. Okay, so if you want to pause the screen and just absorb all this content, go for it. Okay, so when we evaluate logs, so let's round to the nearest 5 decimal places if need be for the first few problems. In other words, I'm going to need a calculator because I'm going to be scratching my head thinking on the side, 10 to what power is 162? Remember, there is no base here, so I don't know what 10 to what power is 162. So let me just get a little thought bubble right there. Okay, so if I plug in log of 162 in the calculator, log 162, I'm going to get 2.209515. If I want 5 decimal places, 20951. Since that's a 5, I'm going to round that to 20952. So log of 162 is approximately 2.20952. Okay. So just to check my work on this problem, let's say I plug in 10 to the 2.20952 in the calculator. I'm going to get 162 0.00185, blah, 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 but basically so close to 162. The more decimal places you use, the more accurate your solution will be. So remember, round to the nearest 5 decimal places. So when we don't have a base, it's automatically base 10. So let's do these two problems just to show that we know how to use the calculator. So log of 81. Well, remember, there is no base given, so it's automatically base 10. Well, luckily for us, our calculator knows base 10. Log of 81. So that's 1.90848. And remember, that's a 5 on the 6 decimal place, so I'm going to round that up to 1.90849. So I'm going to box that, and just to check my work, I'm going to plug in 10 to the 1.90849. And I'm going to get so close to 81. But remember, the more decimal places you use, the more accurate your solution is. I like 5 decimal places myself. And once again, I just picked a random number, a 4-digit number. I just picked log of 1,234. How exciting. So if I plug that into the calculator, the log of 1,234, that is 3.09131. But remember that, luckily for us, it's another 5 in the 6th decimal place. So 3.09132. 3.09132. And you can check your work by plugging in 10 caret 3.09132. So close to 1,234. The more decimal places you use, the more accurate your solution will be. Okay? So I just want to clarify that I am going to touch upon this. So wait a minute. What's this magic trick, Matt? You keep telling us, you just see, that's like log of the argument divided by log of the base. Well, I'm going to explain in further detail in the next unit when we do the properties of logarithms, how to expand a logarithm. I just want you to get familiar with logarithms and what their goal is right now. So just do what I say, all right? No, I'm just kidding. You know I'm going to explain it really well. But for now, to get you an idea of what you're doing. So the textbook gives us what's called the Change of Base Theorem. So let's say you've got log base c of a. That means that it is equal to log base b of a over log base c of a. Log base c of a is equal to log base b of a over log base b of c. And the first time that I saw this when I was in high school, I was completely confused. Let me show you a better way as to what this means. So I'm going to turn the page, and then I'm going to come back to it. So what does the change of base theorem actually mean? So I like to pick the easiest problem that I can think of that isn't like 2 to the 2nd power. So anyway, let's just say we're human. We are human. After all, that's no stretch of the imagination. So the human would solve it like this. 2 to the 1st power is 2. 2 to the 2nd power is 4. And 2 to the 3rd power is 8. We have a winner. This is a whole number. I'm very, very happy. So x has to be equal to 3. And we can check our work by saying 2 to the 3rd power is 8. Therefore, log base 2 of 8 would be 3. However, your calculator, that's just my drawing of a calculator. I know I'm like Picasso. It doesn't know how to do that. However, you must trick the calculator. So you can trick the calculator. It's pretty cool when you think of it this way. You can trick the calculator, okay? Because your calculator doesn't understand base 2 or base 3 or base 4 and so on and so forth. So what you can do is give it this little magic trick, and it says x is equal to the log of 8 divided by the log of 2, and I'll explain it in more detail later, but now that we know what the log button does, I'm going to break this up into 2 steps. I'm going to do I'm going to do red for the top part and green for the green for the bottom part. So remember what log of 8 means in the calculator. So log of 8 means 10 to the x power. Let's just go with x and y. Sorry about that. 10 to the m power is 8. And the bottom part is log of 2, so let's just say it's n. 10 to the n power is 2. And we take m divided by n. So it's kind of like a weird way of thinking. I mean, this works if the exponent is a whole number, but I'm kind of glad that my calculator is a little bit quirky, because it'd be like, hey, 2 to what power is 8? And the calculator goes, hear me out, okay? I don't know, but I'll tell you what I can do. I can say 10 to some power is 8. I can figure that out. I'm really, really good at that. Hey, and 10 to some power is 2. And you know what I can do? I can divide them. So I'm going to get my calculator. This is going to be awesome. So log of 8 in the calculator is 0.903 0899 ... and then log of 2 is 0.301 0299 ... And you're thinking to yourself, well, calculator, how do you know that? Wow. But the point is, you can see that these 3 numbers, if I just cover this part right here, you see 9 divided by 3 is 3. But yeah, the only thing I can tell you for now, before I get into the next unit, is difference between human and calculator. Log base 2, 2 to what power is 8? 2 to what power is 8? The human can do it. The calculator needs to be tricked into base 10. So what does the change of base theorem literally mean? The change of base theorem in my own words is, if the calculator doesn't understand the base 2, base 3, base 4, base 5, and so on and so forth, you can trick the calculator into base 10. You can trick the calculator by changing the base into base 10. That's the main idea of the change of base theorem, is your calculator doesn't understand the base that the problem is giving you, so you have to convert it into a base that it understands. For now, base 10. There is another base that it understands, but for now, base 10. Okay, so now let's do some problems that could be on the test. So let's take a look at log base 5 of 8. Well, this is another way of saying 5 to what power is 8? And so you do your little magic trick, you wave your magic wand, and you get the log of 8 divided by the log of 5. So log of 8 divided by the log of 5 is 1.29203 if I round up. Okay, I'm just going to box that part. So what this means is 5 to the 1.29203 power is 8. So although you're a human and you try to figure out logic, your calculator, you just tell your calculator, like, you do you, man, whatever works, and it does. So in a way, I appreciate its quirks. So let's take a look at number 2. Log base 26 of 9. Well, that is in exponential form. 26 to the x power is equal to 9. So I can do my little magic trick and say x is equal to the log of 9 divided by the log of 26. After all, 26 to the first power is 26. 26 squared is going to be much bigger than 9. So I think it's going to be less than 1. So log of 9 divided by log of 26 is going to be 0.6743, round the last digit up to up one space, so 67439. So approximately 0.67439. We have log base 26 of 9. Okay. Log base 8 of 14. So you guys get the idea. I could just do the log of, let me do, that's an equal sign actually. So you get the idea. I could convert this every single time. 8 to what power is 14? But I know you guys are probably like, let's pick up the pace already. So let's do log of 14 divided by log of 8. So log of 14 divided by log of 8 is 1.26911, and that last place is an 8, so I'm going to make this 1.26912. Okay. Log base 12 of 30, right? That's 12 to what power is 30? So I'm going to rewrite this problem as log of 30 divided by the log of 12. But remember, I don't want you to forget that it's an exponential function in disguise. Log of 30 divided by the log of 12. So that's 1.36874. And the last digit is a 2. So I'm going to round this down, 1.36874. Okay, so let's do these 3 problems, and then we'll go to review the problems that we've seen before. So those are the fun ones that you'll see on the test. But I will put a couple where you do need to round a little bit. So let's do log base 3 of 15. In other words, 3 to what power is 15? Okay, so this is no different than taking the log of 15 divided by the log of 3. So 3 to the first power is 3, 3 squared is 9, 3 to the third is 27. So I have a prediction that that 3 to what power is 15 is going to be somewhere between 2 and 3. So I'm going to round to the nearest 5 decimal places. 2.46497, and the 6th digit is 3, so I'm going to round that down. So 2.46497. Okay? Yeah, that's right. All right, then number 6. Okay, well, log of 365. I just thought of 365 days in a year just for fun. But remember, there's no base. So what is the base automatically? It's 10. So I don't really need to do anything. I like that I don't really need to do anything. So the log of 365 answers the question, 10 to what power is 365? And it makes sense because 10 squared is 100, 10 to the third would be 1,000. So it makes sense that 10 to the, somewhere between 2 and 3 would be around 365. So that's approximately 2.562. And remember, we've got 2 decimal places left. 292. So I'm going to round it down to 229. So 2.56229. Okay, this one I just wanted to have a little fun with because you might see this in pre-calc. They might try to pull a fast one on you. So you've got 7 to what power is the square root of 7? So although you could do it like this, right, so let me just show this the long way. And you could do it like this. The square log of the square root of 7 over log of 7, and for some reason you get 0.5. Okay, so that's 0.5. Another way you could think about this, so that's one way to do it. Another way to do this is, well, you still have 7 to the x power equals the square root of 7. However, what do we know about the square root? Well, the square root is the 1/2 power. So what you do is you go, hey, wait a minute, base 7, base 7. I don't really have to, it's not rocket science. X is equal to 1/2. So in other words, log base 7 of the square root of 7 is 1/2 for that very reason, or 0.5, whichever is your pleasure. Okay? Just wanted to stretch your brain a little bit. So now let's get, I don't want to call this like the real test review. I just want to make sure that you didn't forget about this. Like this is going to be the most prevalent part of the test. Okay, so for instance, I'm just going to cruise on through this. Log base 2 of 64. Remember that this problem is basically 2 to the x power is 64 in disguise. Log base 2 of 64. So our magic trick is log of 64 divided by log of 2. You plug that in the calculator, and I've had years of experience with this. 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth. So 2 to the 6th power is Nintendo 64. So that means log base 2 of 64 is 6. Okay? And of course, number 9, 3 to the x power is 9. So I can rewrite this as log of 9 over log of 3. Or, you guys know this already, 3 to what power is 9? That would be 2. But that's how you would do it with the logarithm in case you're unsure. All right, this is where it gets a little bit tricky, but we are smarter than that. So I just put like a case where, like, you know, when would you get like some sort of relationship between the squares or the square roots or the cubes and the cube roots, and what happens when the base is bigger than the in general, like a whole number is bigger than the one inside. So I just wanted to cover all my bases. Cover all my bases. So you've got 7 to the x power is 1 over 49, where x is the output of the logarithm. So you've got x is equal to the log of 1/49, close the parentheses, divided by the log of 7. Now, 7 squared is 49, but remember, we're getting 1 over 7 squared. So that tells me that it is a negative exponent. You would plug that into the calculator, and you would get negative 2. Okay. Moving on to number 11. Log base 2 of 1/8, we don't know. So we can call this 2 to the x is equal to 1/8. Remember your knowledge of negative exponents. I know that 2 to the third power is 8, but remember we have 1 over 8. So you can use your previous test knowledge to figure this out, Or if you're ever unsure, here's the magic trick. Log of 1/8 divided by log of 2, the change of base theorem. So the change of base theorem would say that 2 to the negative third is 1/8. So log base 2 of 1/8 is -3. Okay. 4 more, and then we'll call it a day, and the test will be due Thursday at 11:59 p.m. Log base 169 of 13. Well, I've got a really big base. 169 to the x power is equal to 13. So how do I solve for the unknown exponent? Logarithm, my magic trick. And then I would notice log of 13 divided by log of 169. Dude, I've got this great idea. So I'm going to say 10 to what power is 13, all right? And then I'm going to do 10 to some power is 169. I'm going to divide them, right? And I'm going to get 0.5. Now you can put the answer as 0.5, or you can use your knowledge and say that the 1/2 power is the square root. So the square root of 169, the square root of 169 is 13. Okay, sorry, that should be a 400. So log base 400 of 1/20. Okay. So 400 to the x power is 1/20. So what does that mean? That means that if I take some power, right? Not only have I gotten 400 into 20, but I've also made it 1/20. So let's examine how we got there. So log of 1/20 divided by log of 400. I'm going to get my calculator. Okay, log of 1/20 divided by log of 400, and I got -0.5. This is twofold. So let's think about this. That's -1/2, correct? Remember that if I take 400 to the -1/2 power, that's 1/400 to the 1/2 power because of the negative exponent rule. And the 1/2 power is equivalent to the square root. And the square root of 400 is 20. So that's why this rule is what it is. Okay. All right, number 14 and number 15, and then we'll call it a day. So I just wanted to switch them around just to get you guys the relationship between these two. So remember that we've got 32 to some power is 16 because we've got log base 32 of 16. Okay, so now I can do x is equal to the log of 16 divided by the log of 32. And let's see what we get when we do log of 16 divided by the log of 32. I'm going to get 0.8. I'm okay with you guys writing 0.8 as your solution, but if you remember a thing or two about fractions, 0.8 is 8/10, 8 over 10, which can be reduced to 4/5. So if you really want to impress me, try the fraction, but if not, 0.8 is good enough. Okay, I'm not going to get mad if you write it as a decimal. But just to show you guys, the 5th root of 32 is 2, and then 2 to the 4th power is 16, so that's why 32 to the 4/5 power is 16. Okay? Let me try it the other way around. So in this case, I've got 16 to the unknown power is equal to 32, because the base is 16, and the argument is 32. So now I'm going to do my magic trick, which states that the log of 32 divided by the log of 16 is going to be some number. Log of 32, I lost my train of thought and I went, some number. Log of 32 divided by log of 16 is 1.25. And I'm okay with you guys writing it as a decimal. So in other words, if you think about quarters, $1.25 would be 5 quarters, so that'd be 5/4. Let me make that in red so it's easy to see. Which makes sense because if I took the fourth root of 16, 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is 2, and then 2 to the 5th power is 32. And that's why it is what it is. So good luck to you guys. If you have any questions, please email me. But remember, the test is due Thursday at 11:59 p.m. Have a great day, and I'll see you for the next log unit on Friday.